We are now into Chapter 3 on differentiation, and this is Section 3.1, tangents and the derivative at a point. And this is example 24 in your notes. So in Part A, you're asked to find the slope of the curve y equals 1 over x at any point x equals a, as long as a does not equal 0. What is the slope at the point x equals minus 1? So first of all, we're going to do it for general any point x equals a. So the function that we're talking about, f of x, is 1 over x. And the x naught that's in the definition of the slope of any tangent line is the x equals a. The a is the rx naught. So in the definition for the slope of any curve, the tangent line to that curve, m is the limit as h approaches 0 of f of x naught plus h minus f of x naught over h. So that's just the definition, and that's what you need to have memorized or written down. So the function right now is 1 over x. So f of x naught plus h, well, x naught is a. So f of a plus h means you take a plus h and stick it in for x into f of x. So 1 over a plus h minus f of a would be minus 1 over a, all divided by h. So now what we need to do is we need to simplify this algebraically. So this 1 over a plus h minus 1 over a is subtracting two fractions. So we need to bring that together into one fraction. So the common denominator is a times a plus h. So a times a plus h, and you can think of this as cross multiplying. So it would be a minus a plus h divided by a times a plus h. And then that fraction is still divided by h. So note, when you're taking a fraction and you're dividing by a number, that's the same thing as taking that fraction and multiplying by 1 over h. So thus you can write this as 1 over h times that fraction. Notice I've already canceled out these two a's. A minus a is 0. You're left with minus h in the numerator. So minus h over h times a times the quantity a plus h. These h's cancel. You're left with minus 1 over a times the quantity a plus h. We can finally evaluate the limit. Note that I was writing the limit at every step because we haven't actually evaluated it. We can finally evaluate the limit by plugging in h equals 0. So you get minus 1 over a times a, or minus 1 over a squared. So when x is equal to minus 1, our a value is minus 1. So when x is minus 1, or a is minus 1, then the slope would be minus 1 over the quantity minus 1 squared, or just minus 1. In Part B, we ask, where does the slope equal minus 1/4? So in other words, what value of x does the slope equal minus 1/4? So that's just trying to solve for a, figuring out what value of a would make our slope minus 1/4. So you set the slope minus 1 over a squared equal to minus 1/4. And then you solve for a. So you can see that a squared has to be 4, or a equals plus or minus 2. So the slope is minus 1/4 when x equals plus or minus 2. All right. In Part C, it says what happens to the tangent to the curve at the point a, comma 1 over a. Right, when x is a, the function is 1 over x, so 1 over a is the y value, as a changes. So as a approaches 0 from the left, you have your slope approaching minus 1 over 0 from the left is a tiny negative number. When you square it, it becomes a tiny positive number. So minus 1 over a tiny positive number is going to minus infinity. As a approaches 0 from the right, the slope approaches minus 1 over a tiny positive number. 0 from the right squared is still a tiny positive number, so that also approaches minus infinity. And then as a approaches either plus or minus infinity, you can see that minus 1 over a squared, or minus 1 over a huge, huge number, approaches 0. And you can kind of see all the stuff that we just talked about in these two pictures here.